Hello everyone. In this video, I'm going to go over how to calibrate the NanoVNA prior to your measurement, as well as account for discrepancies between your fabricated patch and the patch that you simulated in HFSS. So the first thing you're going to want to do is calibrate the NanoVNA. So after you switch it on, you'll click the menu button here, pull up the menu. You're going to click on Stimulus. And we'll set our frequency range. So start it at 700 megahertz. So type 700 and then M. And we'll stop the frequency range at 1.1 gigahertz. So once you have that set up, we need to calibrate the NanoVNA. To do that, we take one of these blue cables and we're going to connect it to port 1, shown here, on the NanoVNA. So you tighten the bolt while holding the cable still and just rotating the nut such that the pin gets depressed into the socket. Once that's tightened, you need to locate your 3 calibration standards. You have a short, an open, and a load. The short is just going to look like a piece of metal right here. So it's got a sort of a shiny backing to it. The load is the silver one, with sort of a white coating on the inside. And then the open circuit standard looks like it has some sort of hole at the back of it. So what you're going to do is take the female to female connector here and put it at the end of your blue cable. So screw that in the same way, making sure only to rotate the nut. Tighten that as much as you can. Okay, and then on your NanoVNA, click the screen, go to Calibrate, and then first we'll connect the open standard. So that's the standard that looks like this, has sort of a hole in the back of it. Just screw it. This is going to be, I always like to think of the right-hand rules. If you put your thumb along the pin, then you twist along the direction of your fingers in order to tighten the standard. So you're going to rotate the standard until it's sufficiently snug, just finger tight. And you want it to be pretty firm connection, and click open. And then wait a few seconds. It's going to measure the open standard. When it turns black, you know that it's complete. So then you're going to disconnect the open standard, connect the short standard, which again, that looks just like a piece of metal, right? You're going to connect that to the end of the line. Click short. There it is. And then finally do the load standard. And that is the silver standard that has the sort of white backing in the back. Make sure again it's quite snug. Click load. Okay. So after you've taken those 3 measurements, if we were doing a 2-port network measurement, then we would have to do one more calibration standard. But because we're only going to be measuring 1 port, we can go ahead and press done. So you can disconnect both the calibration standard as well as the female to female connector, and click done. So what you should see is that your phase of the S parameter is going, of the reflection coefficient is going to look as though it's slightly greater than 0. This is because we effectively taken off a little bit of electrical length. But effectively we have an open circuit right now at the end of the line. Okay, so that's calibration. But the next thing you're going to want to do is, when we fabricate the patch, there'll be slight differences between your simulation and the actual design, and this is going to lead to a shift in the resonant frequency. So we're going to talk about how to account for a shift in your resonant frequency upwards and downwards. So if your resonant frequency is too low, that means the effective length of your patch is too long. So suppose, we've designed it for 900 megahertz. and the resonant frequency is like 850 megahertz or 890 megahertz, then what we're going to do is we're going to take a small cut off the end of the patch. So let's see if I can get a good angle of that. Okay, so what you need to do is, I'm sorry guys here, let's get a nice low profile here. Okay, so you want to find some sort of corner like this, and your patch will have an SMA on the back. So you're going to hang the SMA off the edge, off of one edge of the table, and then you need some sort of a straight edge. If you don't have an actual straight edge, you can use a block of wood or something with a straight, flat edge that you can cut against. So a block of wood would be preferable, or a straight edge. And you're going to set that up against your antenna, and you'll also need a box cutter. And if we make a cut off the edge of the antenna about the width of the knife itself, that's going to correspond to roughly a 5 megahertz shift. So suppose we want to shift the resonant frequency up a little bit by about 5 megahertz. What we'll do is we'll set up our straight edge. So we just see the edge of the copper coming out. We'll apply pressure at the end of the knife, and being sure to apply downward pressure, not backwards, so you don't cut yourself. Just make a few cuts down the copper, making sure that the cuts are kind of deep because we're going to scrape off the edge of this copper. Okay, so now what you've got is a cut that looks like that. Let's see if you can get it. You've got a cut at the end of the patch. So what you'll do is, at the end of this cut section, you're going to use your box cutter and just scrape off that edge. Let's see, here we go. There we go. You should see it sort of start to peel up. And it's okay if you get a little bit of scratching on your substrate. It shouldn't be too big of an effect. So you're going to push. You should see it again start to sort of peel up. So I made that cut a little too thick. So this patch was resonating at about 920 before. Again, you designed it for 900 megahertz, but for the purpose of the demonstration, I'm first showing how to address low resonant frequencies. Okay, when you're confident you've removed all the copper from the edge, you're going to wipe that off and go ahead and connect it to the end of your NanoVNA. So go over here. Again, try only to twist the nut, not the antenna. Okay, so right now, the NanoVNA is showing that the resonant frequency is, by the way, you can turn on markers in the resonant frequency. I think you click the screen. Yeah, go to marker. And then you can even do search minimum, and it'll put the marker right on the minimum. So that's now at 932. So I moved it by 12 megahertz, which is more than I intended. But, so that's just because I made the cut too thick. Okay, but suppose that you made that error and now you want to correct for it. So now we want to shift the resonant frequency in the opposite direction. We want to shift the resonant frequency downwards, back towards 900 megahertz. Well, ideally, you would have a piece of copper tape, and you would cut it out such that the width, I'm going to show with foil, but you would cut the copper tape out so that the width matches that of your patch, and you would just sort of hang the copper tape off the edge of your patch to effectively increase that length, right? Now, if you don't have copper tape, foil works just fine, like regular kitchen foil. And because the current is mostly on the bottom of the patch, If you put tape on the top, it doesn't really have an effect. So what we can do is, I'm gonna show you how to do this with foil. You take a piece of foil and you cut the edges that such that it fits the width of the patch. And then really, again, for 5 megahertz increments, you only need to go about 1 millimeter at a time. So you're gonna ever so slightly push it beyond the edge of the patch. Let's see, I think this side's a bit straighter. So push your foil beyond the edge of the patch a little bit. Let's see, put it just beyond the edge of the patch. Take some regular Scotch tape and tape it down on the top. There we go, that's one. There we go. You probably don't need that much tape, honestly, because if you need to move it back and forth, it's kind of hard to move it once you tape it that much. But once you find that final position, it's good to really put it down, especially if you're using foil instead of copper tape. Okay, so and then you want to try to use as little tape on the radiating edge, because this is the radiating edge here on this end. I'm gonna use as little tape as possible on that edge so it doesn't interfere with our radiation. So put a little piece of tape just off the one side, and then a little piece of tape right on the other corner. And that tape's going between the foil and the substrate. Okay, so there's that. Now, you probably can't see the NanoVNA that well, but take my word for it. I'll say that it works anyway, even if it doesn't. Okay, so now, let's see. Sometimes you have to rotate the patch a little bit when you're tightening it, because the wire's gonna wanna sort of twist it the other direction once you're done tightening. So when you've got that tightened, okay, so now the resonant frequency has been shifted down, and I need to include a little bit more length because it's not quite there, but it's been shifted down now to 912 megahertz. So that's how you can do your adjustments. Again, it's better if you use copper tape because it'll stick a little bit better to the edge of your patch here, but foil and Scotch tape, if that's all you have, that works just as well. Again, email if you have any questions. Thanks.